Ever walk into a room and just completely forget why you're there?
Happens to the best of us, am I right?
It really does. It's like until that thought pops into your head, all those possible reasons, grabbing a glass of water, finding your phone, maybe you were going to do a little dance break, they're all happening at once.
Okay, I like that analogy.
Well, get ready for that feeling, but on a, shall we say, slightly grander scale, because today we are diving headfirst into the mind-bending world of Schrodinger's cat.
Ah, yes, Schrodinger's cat. The thought experiment that never seems to get old, does it?
Well, it's one of those physics concepts that's as fascinating as it is confusing. So, for those of us who might not have a PhD in quantum mechanics, can you give us a little refresher? What exactly are we talking about when we talk about Schrodinger's cat?
So, at its core, Schrodinger's cat is the thought experiment, right? It's not a real experiment. We're not out here stuffing cats into boxes.
Well, I certainly hope not.
No, no, of course not. But it's a way for us to get our heads around a very strange, a very non-intuitive concept in quantum mechanics called quantum superposition.
Quantum superposition. Okay, that sounds a little intimidating.
It's really not as complicated as it sounds. Basically, it means that a quantum particle, like an atom, can exist in multiple states at the same time, until we try to measure it, that is.
So it's like that moment before you check your lottery ticket. You could be a millionaire, you could be completely broke, you're both
You
until...
got it. You're both simultaneously until you actually look at the ticket and collapse those possibilities into a single reality, which, in the case of a lottery ticket, let's be honest, is usually disappointing. But with Schrodinger's cat, the stakes are a little higher, at least for the hypothetical cat.
Okay, I'm hooked. So how does a cat, even a hypothetical one, help us understand all of this? Walk us through the thought experiment.
All right, so picture this. We've got a cat. We put that cat in a box. Now, inside this box, we also have a tiny bit of a radioactive substance, like a really, really tiny amount, and a device that can detect if one of the atoms in that substance decays.
And I'm guessing the cat's fate is tied to this radioactive substance.
Exactly. So let's say there's a 50-50 chance that one of these atoms will decay in the next hour. If it does decay, it triggers this device, which, well, let's just say it leads to a very unfortunate outcome for our feline friend.
Okay, that's pretty dark, even for a hypothetical cat.
It is a little grim, but that's kind of the point. Because here's where the quantum superposition comes in. Until we open that box, we don't know if the atom has decayed or not.
Right.
So according to quantum mechanics, the atom is in a superposition of both states. It's both decayed and undecayed at the same time.
Okay, I think I'm starting to get it. So the cat is both alive and dead.
Precisely. Until we make a measurement, in this case opening the box, the cat is in this fuzzy, undefined state of being both alive and dead. It's only when we observe the system, when we open the box and look inside, that the wave function collapses.
The wave function collapses and we force the cat into one state or the other.
Exactly. And that is where things start to get really interesting, because it suggests that the act of observation, our interaction with the system, actually determines the outcome.
So our observation shapes reality.
In a way, yes. But it's important to remember that we're talking about the quantum world here, which operates under very different rules than our macroscopic world. Quantum superposition is a very real phenomenon, but is mostly observed at the subatomic level.
So no matter how hard I stare at that toast, it's not going to unburn itself.
Probably not, no. But you never know.
So where does this leave us? If our observations can affect reality at the quantum level, what does that mean for us in our everyday lives?
Well, that's where things get a little more philosophical. There's a lot of debate about whether and how these quantum principles apply to the macroscopic world.
Speaking of debate, we've got to talk about the Copenhagen interpretation.
Ah, yes, the Copenhagen interpretation. One of the most famous and controversial interpretations of quantum mechanics. Essentially, it says that it's not just particles that exist in superposition, but reality itself. Until it's observed, of course.
So every possibility, every potential outcome, they all exist simultaneously until we make a choice. And that choice determines which reality we end up in.
That's the gist of it, yes. It gets pretty mind-boggling pretty quickly.
Mind-boggling is an understatement, but it's also incredibly fascinating. So for our listeners who are maybe feeling a little overwhelmed by all this talk of quantum mechanics and collapsing wave functions, what's the key takeaway here? Why should we care about Schrödinger's cat?
That's a great question. You know, at its heart, Schrödinger's cat, while firmly rooted in the world of physics, it's also a powerful metaphor. It reminds us that the universe is a fundamentally uncertain place. That even when we think we have things figured out, There's always the possibility for surprise.
And maybe a little bit of wonder.
Absolutely. Wonder, the unknown, is what drives us to explore, to question, to push the boundaries of what we think is possible.
And speaking of pushing boundaries, who knows, maybe one day we'll have a definitive answer to the question of whether or not our observation truly does shape reality. But until then, I think I'll hold on to that sense of wonder. This has been another deep dive, folks, reminding us that sometimes the most profound truths are hidden in the most unexpected places, like inside a box with a cat.